Assalamu alaikum everyone, I hope you all are fine. We'll start second chapter today, which is natural numbers and whole numbers. Let's start. Natural numbers. The numbers used for counting objects around us are called natural or counting numbers. So natural numbers starts from 1 and the set of natural numbers is written as 1, 2, 3, 4 and up to infinity. So the smallest natural number is 1. The smallest natural number is 1, and there is no largest number in this set because it has endless counting numbers. That is why we write the set of natural numbers like this. So these are the natural numbers and they form the basis of all mathematics because we can we can measure things using these numbers. Okay, and 0 is not natural number. 0 is not natural number. Now let's move on to the whole numbers. The numbers consisting of 0 and all natural numbers are called whole numbers. So consisting of 0. So the whole numbers start from 0. The set of whole numbers is written as 0, 1, 2, 3, 4 and up to so on. So the 0 is not natural number but 0 is a whole numbers. Natural numbers start from 1 and the whole numbers start from 0. So 0 is the smallest whole number here and there is no largest number because it has similarly it has endless numbers, and all the natural numbers are present in this set. It means that the set of natural numbers is subset of set of whole numbers because all the natural numbers are whole numbers but not all the whole numbers are natural numbers because 0 is a whole number but 0 is not a natural numbers. Okay, now we will discuss the properties of 0 and 1. Okay, first we will discuss the additive identity. If 0 is added to any number, the identity of the number doesn't change. So 0 is the additive identity here. It means that if I add 0 to 4, then we get 4. So the 4, the identity of this number doesn't change when we add 0 into it. Similarly, if I add 0 into 115, we get 115. So here the identity also didn't change. So 0 is the additive identity because it doesn't change the identity of a number into which it is added. Okay, now what is multiplicative identity? Multiplication of any whole number by 1 leaves the whole number unchanged. It means that whenever we multiply a number with 1, this number remains unchanged. Similarly, if I add 112 with 1, what do we get? We get 112. So the whole number doesn't change, it remains same. So 1 is the multiplicative identity because when you multiply 1 with any number, the number doesn't change, and when we add 0 to any number, the identity of that number doesn't change. So 0 is the additive identity and 1 is the multiplicative identity. Now we will discuss the properties. Okay, operations with natural and whole numbers. The first property we are going to discuss is clear property. If performing an operation on any two numbers in a set always results in a number in that set, the set is closed under that operation. It means that if we are performing operations on two natural numbers and the result we get is also a natural number, is also belong from that set, then that set is closed. Then the clear property holds in that set. For example, if I add two natural numbers like 10 plus 90, the result is 100, which is also a natural numbers. So the clear property holds here. And if I add, similarly, if I add two whole numbers like 0 plus 10, then the answer is 10. It is also an whole number. So clear property also holds here. So clear property holds for addition. But now let's see that does it also hold for subtraction? If I subtract two numbers, 2 minus 3, then what do we get? We get minus 1, which is not a natural number. 2 is a natural number, 3 is a natural number, but minus 1 is not a natural number. It is an integer. It means that Claire property doesn't hold for subtraction, because when we subtract two whole numbers or two natural numbers, it is not necessary to always get a natural number or whole number in a result. So Claire property holds for addition, but it doesn't hold for subtraction. Now let's see for multiplication. When we multiply two natural numbers, do we get a natural number in answer? Let's see. If I add 2 and 12, the answer is 24, which is natural number. So 2 and 12 are natural numbers, and when we multiply them, the answer is also natural number. So Claire property holds for multiplication. And if I add two whole numbers, like if I multiply 0 with 55, then the answer is 0, because whenever we multiply a number with 0, we get 0, so which is a whole number. So the multiplication holds for, the Claire property holds for multiplication and addition, but it doesn't hold for subtraction. Okay, the next one is commutative property. In commutative property, if we add two numbers, two whole numbers or natural numbers, and if the sum of two whole numbers or natural numbers remains unchanged if the numbers interchange their places, it means that if we change the order of numbers and the result is still same, then the commutative property holds there. Let's see, if I add two natural numbers, 7 plus 8, the result is 15. And if I change their order, like I add 8 plus 7, I write 8 first and 7 later, then the result is again 15. So the orders doesn't matter when we are adding two whole numbers or two natural numbers. So it means that commutative property holds for addition. Now let's see, does it also hold for subtraction? If I subtract 7 from 8 or 8 from 7, here the answer is minus 1, but here the answer is plus 1. So the answer is not same. It means that commutative property also doesn't hold for subtraction. And now let's see for multiplication. If we subtract 7 and 8, the answer is 56. And if I multiply 8 with 7, then the answer is again 56. So the commutative property holds for addition and multiplication, but it doesn't hold for subtraction. It does hold for addition and multiplication, because when we change the order while multiplying two numbers, the result doesn't change, it remains same. And similarly for multiplication, so the commutative property holds for addition and multiplication, but not for subtraction. Now the next one is associative property. Okay, it means in this property, if we are dealing with three numbers, it means that the sum of three numbers remains unchanged if the order in which they are grouped is changed. Let's see an example. 2 plus 3 plus 7. Now we are going to add 2 and 3 first. If we add 2 and 3 first, 5 plus 7. Then 5 plus 7 is 12. Now let's see what happens if I add 3 and 7 first, because we have to change the order in which they are placed. And 7 plus 3 is 10, and again 10 plus 2 is 12. It means that this and this one is equal. So the result doesn't change if the order is changed, if the order in which the numbers are placed is changed here, because here we added 2 and 3 first, and here we added 3 and 7 first, but in both cases the result is same. So the associative property holds for addition. Now let's see for the subtraction. Does it also hold in case of subtraction and multiplication? Associative property holds for multiplication because the result doesn't change if we change the order while doing multiplication. First, let's see for the subtraction. 7 minus 5 minus 2. 7 minus 5 minus 2. Here I will subtract these two numbers first, and here I will subtract these two numbers first because we have to change the order. Now 7 minus 5 is 2 and 2 minus 2 is 0. But here we have to subtract first these two numbers, and 5 minus 2 is 3 and 7 minus 3 is 4. See, the result is not same. They are not equal. 0 is not equal to 4. It means that associative property doesn't hold for subtraction because when we change the order, the result get changed. Now let's check for the multiplication. I will use these same numbers but change the operation here. Now here they are getting multiplied. Okay, 7 multiplied by 5 is 30 and 35 twos are 70. And here we have to multiply these two numbers first, 10 and 10 sevens are 70. So see, the result is same. It means that associative property holds for subtraction, holds for multiplication and addition, but doesn't hold for subtraction. Now let's move on to the last property, which is distributive property of multiplication over addition. So here we are dealing with two operations, multiplication as well as addition. Okay, so in this property, the product of whole number and the sum of two or more whole numbers grouped together is equal to the sum of the products of the former number in each of the grouped numbers. For example, 5 multiplied by 6 plus 7. Let's see. 5 multiplied by 6 plus 7 is 13 and 5 multiplied by 13 is 65. So here what we did is the product of whole number and the sum of two whole numbers. If we have grouped them in this form, we get 65. Now let's change the order in which they are grouped. Now we will multiply 5 with 6 plus 5 with 7. Let's see the result. So what we did is we multiplied this 5 with 6 first and then with 7, and the operation here was addition. Let's see the result now. 5 multiplied by 6 is 30 because we solved the brackets first, and 5 multiplied by 7 is 35. So the answer is same. It means that it holds for multiplication over addition. Okay, so this is the distributive property of multiplication over addition. On left hand side we add two numbers and then multiply with the whole number, and right hand side what we do is we multiply that whole number with the two numbers here separately and then we add them. So the result is same. So the distributive property holds for multiplication over addition. Okay, now we have discussed all the properties, but we just applied these properties on addition, subtraction and multiplication. We didn't check them in case of division. So now your homework is to check that whether commutative property also holds for division or not. Similarly, associative property and Closure property. You don't need to check the distributive property because for now it is only for the multiplication over addition. So you have to check for the associative, commutative and Closure property in case of division. And if you have any question, then you can contact on school's contact number. Thank you. Allah Hafiz.